Yeah, so we will use I would use the ladder method, so we're writing it as a product of its prime factors. Okay. So let's just break this down quickly to get our grammar right. So we want product. What does product mean? Endpoint of what? Of the equation. So if I say what is the product of 5 and 2, can I say 5 plus 2? Well, so is 5 plus 2, is the product of 5 and 2 then 7? What is it? So if I say 5 plus 2, is this my product? No. This will be... This is my product. Because product is multiplication. It is the endpoint of multiplication. Okay. Now, I had a teacher, I think it was Miss Reinertson, and I couldn't stand her, but she forced me to learn these things. It was great. Now, product of prime factors. Now, what is a prime number? Let's be a little bit more specific about it though. So yes, but also it has to be positive and a natural number. Okay. Now, what is the difference between a natural number and a whole number? No. A natural number starts at 1, a whole number starts at 0. Whereas an integer can be negative. Okay. So we can do -5, -4, 3, 4, 5. Okay. So that's product of prime factors. Now let's do one more. Factors. Let me just quickly get my background here because I really dig this background. Do you like my background that I made? Yes. It's supposed to be like honey dripping. Doesn't honey drip? It's like honey flowing out of a honey thing. I don't know. Okay. So factors. Why? Okay. So factors are things that make up a number. Okay. So factors of 5 could be 5 times 1. Factors of 7, factors of 10 could be, so I could work that out, and that could be 1 times 10, 2 times 5, and pretty much that. So my factors we could write it in this notation. So it would be 1, 2, 5, and 10. Is that cool? Okay. So now let's look at, just delete this. Let me actually just use my eraser here. So if I want to write it as a product of its prime factors, I've got 180. Okay. So 180, this is a logic question, so I'm going to make it green. I'm going to use my ladder method. So, oh wait, it must be the other way. 2 lines down. Like that, and you break it down like that. Yes, you can do that. I don't usually do it for prime factorization though. But it's kind of the same thing. This works out neater when you're working out. So we're going to look for our lowest prime number that fits into this. So prime number, it can only be 1 in itself. So 2. So we're left with 90. 2 can go into that again. We're left with 45. Then we've got 5. So that's going to be 9. Then we've got 3, 3, 3, 1. So to write it as a product of its prime factors, these are all the prime factors. So if I say 2 times 2 times 5 times 3 times 3, I will get 180. Okay. So then what I would do is I've got 2 times 2 times 5 times 3 times 3. Now this is technically correct because it is a product of its prime factors, but we should simplify it. Okay, so this is 2 times 2 would be 2 squared times 5 times 3 squared. Okay, but this is still a little bit messy, right? Because they're not in the right order. I mean, imagine I've got an autistic son. He would look at this and be like, Dad, that's wrong. No, he wouldn't. But it should be 2 squared times 3 squared times 5. And then we don't have to take it this step, but we could even take it further and say 2 squared, 3 squared, 5. Okay. Is that cool? So that would be our product of prime factors. Which question was this? This is question 6, hey? So we're going to write 2 squared times 3 squared times 5. Okay.
I hear the buzz around. We fly with skies and trees. We break the chains that bind. Take lessons from the bees. From hype to moving parts. They teach us how to stop. Bring